Hello everybody. Today's topic is marine drugs. Today's video is specially useful for the B Pharmacy second year students and this topic is related to PCI syllabus. So what are marine drugs? These are the drugs which are obtained from marine sources, which is a natural source to obtain natural drugs. Next, coming to the introduction of marine drugs. The drugs obtained from marine organisms which are being conventionally used like shark and cod liver oils, sodium alginate, agar-agar and chitin, etc. Next, importance of marine drugs. Marine organisms are potential source for drug discovery. Life has originated from the oceans that cover over 70% of the surface of Earth and contain highly ecological, chemical, and biological diversity, starting from microorganisms to vertebrates. This diversity has been the source of unique chemical compounds, which hold tremendous pharmaceutical potential. Because of the highly chemical and physical harsh conditions in marine environment, the organisms produce a variety of molecules with unique structural features and exhibit various types of biological activities. Majority of the marine natural products have been isolated from sponges, coelentrates like sea whips, sea fans, soft corals, and tunicates, echinoderms like starfish, sea cucumbers, etc., and bryozoans, and a wide variety of marine organisms in their tissues. Now let's have a look at classification of drugs from marine organisms. So based on the pharmacological action, the marine drugs are classified into different classes. The first one is cytotoxic or anti-neoplastic agents. These are nothing but anti-cancer drugs, which is useful for treating cancer. The next one is cardiovascular active drugs. Next is marine toxins. And the fourth one is antimicrobial drugs. Next is antibiotic substances. Next, anti-inflammatory and antispasmodic agents. And the last one is miscellaneous pharmacologically active substances. Coming to the first class, the first one is antimicrobial class. And here, the example of marine drugs include zonerol and isozonerol. The biological source is these are both obtained from Dictyopteris zoneroids, which are nothing but brown algae. Chemically, it is made up of flavonoids and it shows antimicrobial activity. The next example of antimicrobial agent is tetrabromo-2-heptanone. Coming to its biological source, it is obtained from the species Burnemysonia hemifera, nothing but red algae. And it is mainly bromophenol compound, which shows antimicrobial activity. The third example of antimicrobial agent is 2-cyano-4,5-dibromopyrrole. It is one of the rarest examples of a chemical entity isolated from a marine organism which contains a cyanofunction group. Coming to its biological source, it is obtained from Agellas oroides, which is a specific type of sponge found in marine sources. The fourth antimicrobial agent is unicin, which is obtained from Gorgonian corals. Nothing but the biological name is Inicea mammosa, and chemically it is a diterpene, which shows antimicrobial action. Next class of marine drugs are anti-cancer drugs. So coming to the first example, simularin, and its biological source is soft coral, Sinularia flebilis. Chemically, it is sembranoids, that is 14 carbon cyclic diterpenoid with eocyclic lactone, and it belongs to the category of anti-cancer. The next example is asperidol, asperdiol. It is obtained from Gorgonian coral Unicea nitti, which is a non-lactone sembranoid. It is specially useful in the treatment of leukemia, nothing but blood cancer. The next example is geranyl hydroquinone, and it is obtained from Aplydium species, and chemically it is quinone in nature, exhibiting anti-cancer properties. The third class is of antibiotics, and the first example is cycloidudecemol, and coming to its biological source, red algae Chondria oppositiclada, and chemically it is sesquiterpenoid, and its use is antibiotic. The next example of antibiotic is variabilin, which is obtained from the sponges, that is Yersinia oros, and chemically it is furanose ester terpene, belonging to the class of antibiotic. Next class of marine drugs include anticoagulants. So the first one is obtained from the organism Iridae laminarioides. Chemically, it is having galactane sulfuric acid. It is anticoagulant in nature. The next anticoagulant is obtained from the organism Cordium fragile, and its species is Leomentocytes. Chemically, it is associated with an unknown plasma factor, and it shows antithrombin activity. Next organism, the anticoagulant obtained from the next organism is Codium fragile. Species is Atlanticum, and it consists of high molecular weight proteoglycans exhibiting anticoagulant activity. The next class include antiparasitic drugs. which is obtained from the organism Digenea simplex, which is nothing but red algae, one of the type of red algae. And chemically, it has alpha canic acid. It is specially useful as a broad-spectrum antihelminthic and effective against parasitic roundworms, whipworm, and tapeworm. The next organism exhibiting antiparasitic activity is Laminaria angustala. Because of the presence of laminin, it is exhibiting antiparasitic activity. Its uses are antihelminthic as well as smooth muscle relaxant and hypotensive. The next organism exhibiting antiparasitic effect is sea cucumber. Chemically, it consists of cumene quinosyte and it shows antiprotozoal action. The next class of drugs belonging to the cardiovascular agents. The first one is eptatritine. The biological source is it is found in bronchial hearts of Pacific hogfish, that is Eptatrestratus stouti. It is a potent cardiac stimulant with direct stimulant action on mammalian myocardium. Next agent, cardiovascular agent is laminin. It is obtained from marine alga Laminaria angustata and it shows hypotensive effect. Nothing but it reduces the blood pressure. The next cardiovascular agent is anthopleurins. It is obtained from coelentrates, that is Anthopleura xanthogrammica. It is one of the species of coelentrates. And its use is cardiotonic, which is 35 times more potent as compared to the plant source, that is digitonin. Next includes marine toxins like ciguatoxin. It is found in red tide dinoflagellate. The biological name is Gambier discus toxicus. It shows the toxic symptoms like neurological, cardiovascular, and GIT disorders. Next toxin is palytoxin, and its biological source is it is present in Palithoa species, and it is especially toxic to coronary arteries. The next class of drugs are antispasmodic agents, which are agelacidin A. Coming to its biological source, it is obtained from Okinawa sea sponge, Agela species. Chemically, it consists of agelacidin A, which is the first marine natural products containing guanine and sulfone units, and it is showing antispasmodic effects. Next class of marine drugs belong to anti-inflammatory action, which is the example is bioindole. Its biosource is it is obtained from marine cyanobacterium rivularia firma. Chemically, it is a bioindole derivative and its use is anti-inflammatory action. And the last anti-inflammatory agent is betanoloide. It is obtained from marine source like Euplexura flava. Euplexara flava, and chemically it consists of butanolide derivative, and it is anti-inflammatory agent. Now let's have a look on the various colorful marine sources from which all these classes of drugs are obtained. So in this slide, you can see the pictures of algae, various varieties of algae. Like the first one, you can see red algae. You can see how colorful it is. Next is green algae, and the next one is brown algae. All the different colors of algae. In this picture, you can see the sponges. These are the pictures of coelentrates. These are the pictures of mollusks, which are nothing but bivalves, octopus, cuttlefish. These are tunicates. And these are the examples of the marine organisms belonging to echinoderms, like starfish, sea lilies, sea urchins, sea cucumber, brittle star, and sand dollar. So these are the various marine sources from which various types of drugs are obtained. So we'll meet in the next class with the next new videos related to pharmacognosy. Thank you.